All right, so we're in my Dodge, trying to figure out what's going on with the engine light and why it runs so poorly. If this video comes out like crap, I'm probably, well, I guess you'll never know about it because I'll never post it, but it's nighttime. Obviously the sun goes down early. I think it's only like 5 o'clock right now, but it's winter. I really wanted to go through diagnosing this truck as far as, you know, drivability, why the engine light's on, why it runs rough intermittently. We also have an ABS light on, so let's see if we can even show this. It's actually not coming out that bad. So we have an engine light on, we have an ABS light on. We have the lamp out warning because we have a bunch of lights out. But for today, we're going to focus on why the check engine light's on and why this thing runs like crap intermittently. Primarily because this is my plow truck. I don't really drive it that often, but I do need it to plow the driveway. So if nothing else, it needs to run right. And then secondly, we need to get all the headlights working. And after that, we'll focus on ABS. So I got the scan tool here. We're using the DRB3. Let's see if we can get this on here. Alrighty. So let's go in and see what we have for fault codes. I feel right now, I don't know if you can see the shake. I'm trying to hold everything straight, but it does have a little bit of a misfired idle right now. Yeah, it's definitely misfiring right now at idle. Alright, so we will pull DTCs. We have 7 fault codes. We have O2 sensor, bank 2, sensor 2, voltage low. We have a heater circuit high for 1-1. We have a NVLD canister vent valve, solenoid high circuit. Fuel system rich, bank 1. Fuel system lean, bank 1. O2 1-1 voltage low. And bank 2 lean. Okay, so those are all our fault codes right now. So, one thing I do know about this truck, and I've kind of been ignoring, but I crawled under there the other day and I realized that I believe it was the drive shaft had eaten some of the harness. So that may be a lot of our trouble codes as far as the O2 sensor codes and stuff go. So a lot of that may be an easy fix. But let's look deeper into how this thing's running. Actually, I should show you what I'm looking at on the scan tool, huh? Instead of looking at me. Why do you want to look at my face for? Alright, so we're back on the scan tool. And we're going to go into OBD2 monitors because I just want to see, it's running really rough right now. I want to see if it's picking up misfires. That'll kind of be a nice clue as to what's going on here. And this is a PID that you only get with like a factory Chrysler scan tool, or maybe a I'm trying to think, I don't even think Autel or any of those scan tools that kind of emulate factory tools would do this. But if you go into OBD2 monitors, you can scroll down to, I'm just flipping pages here, which cylinder is misfiring. And this is going to be your misfire counter right here. And we do have misfires counting up. We have a lot of misfires on cylinder 3. It looks like cylinder 5's counting up pretty readily. 7's counting up a little bit. But it seems like our majority is going to be on cylinder 3 and cylinder 5. You see the counter just reset. Although 7's counting up pretty good. And we also have misfires on 1. So, 1, 3, 5, 7. So it looks like bank 1's misfiring. So let's go back to scan data. So we have an entire bank misfiring. So let's take a look at live data and see what our 2 sensors are doing. Let's go to sensor display. By the way, for those of you who haven't used a DRB3, this thing is ridiculous. It is just a giant scan tool. That hum is the cooling fan on the side of it. So please excuse the hum. We don't really have a way around it right now. These older Chryslers, you know, I don't really trust a lot of aftermarket scan tools on these Chryslers because you get weird codes that don't really make sense and the data can be kind of funky. Newer, like CAN, you know, once they switch to the CAN protocol, it seems like the scan tools got a little more, or the aftermarket scan tools got a little more trustworthy. But these older Chryslers, you know, I'll say pre-2005, 2006, I don't think the Rams got CAN until like 07 or 08, but these early ones, just, man, you got to be careful with the data you're getting out of an aftermarket scan tool. So let's move over to O2 sensor voltages. And we can see that bank 1 sensor 1 is stuck rich. And now what I'm looking at is these ones right here, 0 to 1. So Chrysler O2 sensors typically do not run on a 0 to 1 volt scale. I believe it's 0 to 5 volt scale is what they're running on. So this is kind of like a an equivalency PID, if you will. So we can see that bank 1 sensor 1 is at 2.37 volts. I mean, the sensor's pretty much dead at that voltage. It's not really doing anything. Bank 2 sensor 1 is nice and lively. We see it switching from, you know, 0.8 of a volt down to 0.1 of a volt. Bank 1 sensor 2 is dead at 0 volts, and bank 2 sensor 2 is way high. So looking at the scan data, if you're talking in terms of lean and rich, bank 1 sensor 1 is crazy rich. Bank 2 sensor 1 is relatively normal. Bank 1 sensor 2, that's a downstream in bank 1, is lean. And bank 2 sensor 2 is currently rich. So let's look at fuel trims and see what fuel trims are looking at. They're looking like. So now the bank 1 sensor 1 long-term adaptive. Sorry about the glare. There we go. You can see the fuel trim's at negative 31%. So it's believing the upstream sensor, and it's pulling a crap load of fuel out. It is just, it's just pulling it all out. And then bank 2 sensor 1 long-term adaptive is at 12. I mean, that's a little high. But this right here, we're misfiring on bank 1. Our upstream is stuck rich, and our downstream is stuck lean. And the cylinder's misfiring. So what I'm going to suspect here, and we're going to go out and test it, is that the upstream O2 sensor is actually lying and the downstream sensor is operational as far as bank 1 goes. So if we go back knowing what we know with fuel trims, if we look at bank 1 sensor 1, it's at 2.43 volts. That's telling the computer that that bank is rich. So what the computer's going to do is the computer's going to pull fuel away. In turn, our downstream is showing us that the exhaust is extremely lean. So the computer's listening to the upstream saying, hey, we're rich, pull fuel, when it's really not. It's pulling fuel. The downstream's showing that it's really lean, and the fact that that whole bank's misfiring, again, is telling us that exhaust is really lean. So what we'll do is we will, to prove this, we'll go under the hood and we will put propane into the intake. And if this downstream sensor goes rich, then we know that the exhaust stream is actually rich. and that sensor is lying. So at that point, we'll diagnose the upstream sensor to cure our misfire and that downstream sensor being lean. Then we'll go over and we'll address why this sensor is reading 5 volts or close to 5 volts. I suspect that has something to do with the harness, but we'll attack that when we get to it. So for enrichment purposes, we have a propane tank hooked to the purge line, and what we're going to do is we're going to feed propane into the intake manifold, and that should enrich in the mixture, and it will cause the O2 sensors to go rich. So if that downstream O2 sensor is reading correctly and the car, or that bank 1, it really is running lean, then we should see bank 1 downstream enriching. So let me get a good shot of the screen here. Sorry about the glare. All right, and we'll enrichen it up now. You can hear the engine change. Bank dip. Bank 2 sensor 1 just went crazy rich, and bank 1 sensor 2 just went way rich. So that tells us that at least bank 2 sensor 1 and bank 1 sensor 2 are reading correctly. The other two we need to take a look at, but the engine's smoothed out now too with that enrichment. So what we're going to do is take a look at bank 1 sensor 1 and see why it's stuck at 2.49 volts, 2.5 volts. It's actually, if you look down at the bottom, it's at 5 volts. That's the real voltage, and we'll talk about that, you know, how to read Chrysler O2 sensors. But it's definitely looking at that upstream sensor, suspecting that the mixture is rich, so it's pulling fuel, and it's doing that erroneously and causing the misfire on bank 1. So we'll take a look at the bank 1 sensor 1. We'll take a look at the upstream bank 1 O2 sensor and see if we have a sensor failure or a wiring fault. So quick education on Chrysler oxygen sensors, just to clarify a statement I made earlier. I had said that they run on 5 volts. They actually don't run on 5 volts, but you will see anywhere from 2.5 up to 5 volts, depending on A, the temperature of the sensor, and B, the amount of oxygen in the exhaust. So at its core, this is a standard 0 to 1 volt sensor, like you would see in any vehicle. The heater circuit works fairly normal. You have ground. This goes right to chassis ground, and it's high side control. This is going to be pulse width modulated. But on the signal side, this is where things get a little funky, and they actually use this circuit to diagnose the heater. They don't directly monitor the heater. They're actually going to monitor the result of the heater operating. So it's kind of interesting. So what they'll do for starters is on the return side right here, this is going to be what you would typically see go to ground or sensor ground. This is going to be a 2.5 volt, so 2.5 volt bias on the ground side. So like I said, this is a 0 to 1 volt sensor, and they're going to float it on 2.5 volts. And I was always told they did that because there's a lot of noise on the ground circuit, but I actually recently found some documents on Chrysler's website saying that they actually do that to prevent to prevent the vehicle from going into open loop if the sensor did invert and go below 0 volts, which makes a lot of sense. So anyways, you can have 2.5 volts coming up the return line, and then on the signal line, you're going to have 5 volts coming back. And the way they do this, I'll draw this briefly here. You're going to have your 5 volt regulator, and it's going to go through a high, probably like a mega ohm resistor, and then off to the oxygen sensor, and then off of that you're going to have your A to D converter. So that's going to be your converter that takes the signal from the O2 sensor, converts it to digital, so the PCM knows what to do with it. So basically what they've achieved here is they've created a voltage divider network using the oxygen sensor as the variable resistor. So when the sensor's cold, it's going to have more resistance than this mega ohm resistor in the PCM, and that's going to allow 5 volts to go to the A to D converter. As the O2 heater operates and warms this up, the resistance will go down, and that will allow the 2.5 volt low reference to pull this 5 volts towards 2.5 volts. And basically the PCM is going to calculate how long it took this 5-volt reference to pull down to somewhere around 3.5 volts and determine if the O2 heater is operational. So kind of an interesting system. What does this mean for diagnostic purposes? First of all, your heater circuit, you diagnose like any other circuit. You're going to want to back probe it here with it plugged in, operate the heater, and see if you have a pulse width modulated signal. You can also monitor that with a meter. Meters are going to average your reading. So say you're running 50% duty cycle on a 12-volt line, you'll have about 6 volts on your meter. Not the best way to test it, but if that's all you have on hand, that's definitely a way to do it. Finally, you can also put a bulb, you know, like a incandescent test light across the ground and the power feed, and just see if it lights. You don't want to run a whole lot of amperage through this because you can damage the PCM, but just a standard incandescent test light will definitely do the job. And obviously, you're going to want to, if you're using a scope or a meter, you're going to want to back probe the ground circuit too with it operating and make sure there's no volt drop there. On the signal side, I'll typically test these open circuit. And things get a little weird when you open circuit test stuff. So you would expect to see 5 volts here with this unplugged. I've seen anywhere from 4 to 5 volts. Probably because it's going through this resistor. You would think open circuit, this should not drop any voltage, but it is still tied to an A to D converter. I don't know what effect that has on it. All I know is, in the real world, I've seen 4 to 5 volts on pin 4. That's absolutely normal. You will see 2.5 volts, give or take a little bit, on pin 3. And ultimately, the final test is, once you've verified you're on pin 3 and 4, I will jump these two together with a jumper wire and watch scan data and make sure we see 2.5 volts on the scan tool. If we jump this to this and we see 2.5 volts on the scan tool, we know A, we have 2.5 volts here to here, so that circuit's good. And B, we know that it's getting up to here, so this circuit's good. And we know that the PCM knows how to process that signal. So that's going to be our game plan when we go to the truck. So let's go to the truck and diagnose these O2 sensors. So real quick before we get started with the O2 sensors, we had bank 2 was also a little lean, and now that I look up here, you can see that the flange actually rotted off of the right bank's manifold. So that's going to give us an exhaust leak right there, and that'll make that bank run lean. So we'll fix that. I got one of those 2-piece Sava flanges. Did I mention it was rusty up here? Yeah, welcome to New England. Rust everywhere. Secondly, this is that harness that got caught up on the drive shaft that I talked about, and this actually goes to the ESIM switch. So that explains the evap codes that we had. So I'll fix that off camera. So this is the connector for bank 1, sensor 1. What we're going to do is we're going to go ahead and unplug that. And the first thing we're going to do is check the signal circuits. So we'll unplug it, make sure that we have 2.5 volts on pin 3, and make sure we have 5 volts on pin 4. And then we'll go ahead and jump those together and make sure it shows 2.5 volts on our scan tool. And if it does, then we know that that circuit is good, intact, and the PCM's processing it properly. And we can move over to the heater circuit and make sure that's working right. So one last thing real quick before we get into testing. One thing that you may want to invest in, for doing electrical testing, is a set of front probes. These are the ones from Wacom, and we'll be using these ones for focus. We'll be using these ones for this truck. And two things they do is, for male pins, you can just slide this on. It allows you to do some hands-free testing. Just plug a banana plug into that end. And then for the female ends, it lets you test for proper terminal tension, and you're not going to damage the connector by just cramming any old pin or probe in there. So definitely a great thing to invest in. And then one last little tip before we start testing this. We are going to be jumping out a circuit, and you really want to be careful when you're jumping things out, because you definitely don't want to send ground or power somewhere that it doesn't belong. And even if your wire colors match and everything's right, one last thing you want to look at is typically manufacturers, since O2 circuits are so sensitive to high resistance, they'll gold plate the terminals for the signal side. So if you look here, you can see the top two terminals are just standard plating, and the bottom two are gold plated. Those two bottom ones are going to be your signal circuits. You know they're going to be low current circuits, and you're not going to worry about jumping those out and damaging anything. All right, so we're front probed on pin 4, and the other end of our leads are on ground. We have 3.99 volts, so that is good. And we switched over to pin 3, and we are at 2.4 volts, so pretty close to 2.5 volts. So now what we'll do is we'll go ahead and we will jump these two terminals and see if we have 2.5 volts on our scan tool. So terminals are jumped. Let's go see what the scan tool is. So you can see that bank 1 sensor 1 actual voltage is reading 2.4 volts, just like we read down at the bottom. So we know that that circuit is good. So we'll go ahead now and double check the heater circuit. We'll back probe that, make sure we have power and ground with the heater commanded. And if that's all good, then we'll go ahead and thread a sensor into this thing. So we've gone ahead and back probe pin 2 with our heater commanded. And we're at 2.8 millivolts. So we know that the heater circuit is good on the ground side. So we'll go ahead and we will move the back probe to pin 1 and make sure we have power. So with the scan tool commanding this at about 50% duty cycle, you can see that the voltage is about 7.2 volts, which is give or take half of source voltage. You can see this bottom scale here is fluctuating, indicating a duty cycle signal. The best way to check these is with a scope, but if you don't have one, this is definitely another alternative. Trying to keep things from being too repetitive, I just went ahead and tested the downstream sensor that we were having issues with on bank 2 off camera, and same exact tests, same results. Circuits are good, sensors failed. So we went ahead and replaced the sensors, and this is what we were left with. After 15 winters in New England, these things were pretty well rotted in the pipes, so I actually wound up having to cut the wires off and put a 22mm socket on it with a big long snap-on breaker bar to crack these things free. What we'll do next is we'll go ahead and put that 2-piece flange on. I'll fix those eSIM switch wires off camera. There's really no need to show you guys that. And we'll jump back in the truck and see if it's fixed. It's a little bit better. We'll get the 2-piece flange installed. So now we'll just go ahead and put the fender well in and make sure everything works right. Okay, so now we know about how Chrysler O2 sensors work. I have on the screen actual voltage for 1.1, 1.2, and 2.2. And 1.1 and 2.2 are the ones we were having issues with. And then I have the 0 to 1 PIDs up as well, just because they're a little easier to watch and understand instead of trying to figure out, 2.5 to 3.5 volts. But anyways, we'll fire it up and we will see if these things pull down like they're supposed to and start operating correctly. And I haven't cleared codes yet, and I haven't reset Keep Alive memory because I want to make sure that when the O2 sensors do come online, that the fuel trim issues start correcting themselves, and that's how we'll know that we fixed that issue as well. So we can see that upstream came right online, which is awesome. The downstream is going to take a little bit longer because the downstreams are further back from the manifold. But we can see the two sensors that we replaced, 1.1 and 2.2, they came right online fast. And we can see that 1.2 is starting to pull down as well. That's starting to come online. So that's awesome. So now let's take a look at, you can see how lean that is right now because of the fuel mixture from what it was correcting earlier. So looking at our fuel trims, we can see that the bank 1 short-term adaptive is at positive 26%. So that's trying to correct for the negative 27% that it was at with the faulty O2 sensor. So right away, we know that our fault is fixed with our new O2 sensor. And if we go back to the O2 sensor readings, we can see the sensors online and working like it should. All 4 are now. So that's great. So we'll go ahead now and we'll clear adaptives. Just do a PCM reset. That way the PCM can relearn how the O2 heater works, and it won't have to try so hard to reset that fuel trim. So we will back out. I'm going to cycle the key off and back on. And we will scroll over to miscellaneous functions. And we're going to perform the clear PCM battery disconnect function. This is basically going to act as though you disconnected the battery. So we will hit yes. Memory has been cleared. So at this point, that should have reset our adaptives as well. And there we go, our O2 sensors, they're coming back online again. Everything's operating like it should. We'll see what our fuel trims are doing. I mean, we got to drive it a bit to really get the fuel trims to come around and really see what they're going to do. But short-term trims are right there. You know, -2% at idle, 1.8% positive at idle. You know, we were in the 26, 27% before, so we're definitely good as new. You know, we had that exhaust leak and the two bad O2 sensors. Things are looking good. And the vehicle's running great now, too. So that about wraps up the engine light issue with the Dodge. I think the next thing we'll tackle is going to be the lighting system. And if we get a chance, we'll take a look at the ABS issue. I'm not really that worried about it. The truck hardly leaves the driveway, but I do need the lights to work. And like I said, I need it to run right. A, to get a sticker, and B, because it's my plow truck. So hope this video was helpful to someone. If it was, please give it a thumbs up. If you're new to the channel, please subscribe, and stay tuned for more videos. Thanks for watching.